a high-quality knowledge podcast for hitchhikers traveling the galaxy. This is Lab 42.
On the drive over here about how we usually frame the victory over the pandemic. Society, history books, even Hollywood. It's always a medical drama.
Right, it's a hero narrative. Humanity versus the virus. Biology versus biology.
Exactly. It's contagion in real life.
Yeah.
We picture the tired doctors, the scientists in lab coats.
Needle in the arm.
The needle in the arm. But I've been spending the last few days with this incredible stack of documents you sent over. And it argues the real war wasn't just against biology, it was a war against physics.
Thermodynamics, specifically.
Yeah. Yes, thermodynamic.
It sounds a little abstract, I know. But that's what we're doing here on the deep dive. We take these dense reports and find the story underneath. And this one, well, it's a huge story.
A story about the cold chain.
Right. And the source material makes this compelling case that while discovering the vaccine was a biological triumph, delivering it was all about fighting entropy.
And we're not just talking about a refrigerated truck driving to a local pharmacy.
No, not at all. This is a story about stopping time. It's about engineering artificial winters to save the world.
Engineering artificial winters.
Yeah.
I love that phrase. The deeper I got into chapter 12 of these notes, the more it clicked. We're going to cover the whole journey today, from the molecular chemistry all the way to delivery drones in Rwanda.
It's a wild ride.
But we have to start with the physics. There's a quote in the research from Erwin Schrödinger, the cat guy, that frames this perfectly.
Ah, yes.
He said, "Life is a process of continuing to intake negative entropy from the environment."
And that's such a profound place to start. I mean, entropy is the second law of thermodynamics.
The tendency for everything to fall apart, basically.
Exactly. Everything moves towards disorder, towards equilibrium. A hot coffee gets cold, a building crumbles. It's the slide towards what they call thermodynamic death.
So Schrödinger's saying that life, us, is just a constant fight against that slide.
We are. We eat, we burn energy, we actively maintain our own structure against that chaos. And this deep dive, really, it's about how we had to physically stop these vaccines from sliding into that same death before they could do their job.
So let's look at the patient here. The vaccine itself. Why was this one so hard to keep alive? We've had vaccines for decades that don't need this kind of extreme babying.
Well, it's the weapon we were using, mRNA.
Pfizer and Moderna.
Right. Incredibly powerful, but the source material highlights its fatal flaw, thermodynamic instability.
The notes used an analogy for the lipid nanoparticles, the LNPs, that I thought was perfect.
The sugar glass.
The sugar glass. Thin shards of glass made out of sugar.
And that's a very accurate way to visualize it. You have this precious mRNA code wrapped in a tiny bubble of fat, but in the molecular world, heat isn't just warmth. Heat is vibration.
It's molecules dancing.
Right. And for these fragile sugar glass shells, that dancing is.
Yeah.
It's destructive. The vibration just causes the structure to unravel and tangle up.
So they don't just expire like old milk if they get warm. They physically break apart.
They become chemical garbage. The moment they leave the factory, the clock is ticking. Entropy is pushing them off a cliff.
And that brings us to the number that was all over the news. Minus 70 degrees Celsius.
Minus 70.
Just to put that in perspective for you, where else do we even see temperatures that low?
Almost nowhere on Earth. I mean, your normal flu vaccine is happy in a fridge, 2 to 8 degrees, minus 70. That's colder than the average winter day on Mars.
Colder than Antarctica.
Colder than the deepest ice at Vostok Station, yeah.
So why that specific number? Why not minus 60 or minus 50?
It's all about the math of reaction rates. It's something called the Arrhenius equation.
I saw that in the notes. The formula itself looked terrifying.
Yeah. But the concept is actually pretty simple. It just describes the link between temperature and the speed of a chemical reaction. And it's exponential.
So you're not just slowing it down a little, you're slamming on the brakes.
You are putting a straitjacket on the molecules. You are physically stopping that dance. You're forcing the Brownian motion, that random jiggling, to almost zero.
So minus 70 isn't just cold, it's a pause button.
It's an attempt to stop time.
Okay, so we have this incredibly fragile glass ornament that shatters if it vibrates.
Yeah.
And we need to ship it across the planet inside a simulated Martian winter.
And that gets us to the logistics.
Which is where it gets really interesting, because normal logistics, Amazon, FedEx, that's all about managing distance. getting a box from A to B.
But this is different. Cold chain logistics is about managing melting time.
That's the key distinction, isn't it?
Absolutely. If a truck of T-shirts breaks down for 6 hours, the T-shirts are late. If a truck with these vaccines breaks down, the cargo is destroyed.
And the main weapon in that fight was dry ice.
Solid carbon dioxide. It sublimates turns straight from a solid to a gas at minus 78.5 degrees. It was really the only way.
But this is where the story has this twist that I just had not heard before. Right when we needed the most dry ice in history, there was a shortage.
A global shortage. It's a perfect example of the butterfly effect in a supply chain.
Walk us through that. Why was there no ice?
Well, where does industrial CO2 come from? We don't mine it. It's a byproduct of oil refining and ethanol production.
And in 2020,
The lockdowns happen.
everyone stopped driving.
Exactly. People stopped driving, so oil refining just plummeted. Demand for ethanol for fuel dropped off a cliff, so the raw material for dry ice just vanished at the exact moment we needed it most.
You can't make that up. So how did they solve that if the ice was so scarce?
They had to be incredibly efficient. So Pfizer's engineers designed this thing called the thermal shipper. The source says it looks like a pizza box but acts like a spaceship.
I looked this up. It's amazing. They couldn't use styrofoam.
No, styrofoam is for keeping your coffee warm. This thing used aerogel and vacuum panels. It's NASA tech, basically.
And inside, they packed exactly 23 kilograms of dry ice pellets.
But the craziest part isn't the insulation, it's the SPY inside the box.
The IoT unit.
Yes. Every single one of these boxes had a thermal sensor and a GPS transmitting data every 5 minutes.
They had a literal control tower watching these boxes.
Right, and they weren't just tracking where the box was, they were tracking how it was feeling.
If it got too warm on a tarmac in Dubai, they'd get an alert.
Instantly. The source compares the whole thing to Formula One racing. They set up re-icing centers.
That's a great analogy. The truck doesn't stop to refuel the engine.
It stops to refill the cold time. They were literally topping up the time they had left before Entropy won.
Refilling the time. I love that. But, okay, that's the artery of the system, right? Moving these space-age pizza boxes between major cities.
The easy part,
Right.
relatively speaking.
But what happens when you hit the last mile? Getting this stuff to a remote village in, say, rural Africa.
This is where the physics gets even trickier. The source uses the analogy of blood flow. Aorta versus a capillary.
The Hagen-Poiseuille Law.
Yeah, you've been doing your homework.
I tried. So if I have this right, if you cut a pipe's width in half, the resistance goes up 16 times.
That's it. It's a fourth power relationship. So a wide highway is an aorta, easy flow, but a washed out rural road, that's a capillary, the resistance just skyrockets.
The source also uses a coffee filter analogy.
Percolation, right. If the coffee grounds are too dense, the water just stops. It can't get through. And if the infrastructure is too poor, the flow of vaccines just stops.
So you needed some kind of catalyst, something to lower that barrier.
And that brings us to the Arctic.
This thing is amazing. It looks like a blue water jug you'd take camping.
But it's a super thermos. The stats on it they're just mind-blowing.
It keeps things cold for 35 days with no electricity.
And that's the key. No electricity needed.
Yeah.
You can strap this thing to a camel, and there are pictures of this, or carry it on your back.
It lowers the activation energy.
Exactly. It turns a logistical nightmare into just a walking trip.
But sometimes walking isn't fast enough. And this is where the zipline drones come in.
Right. And the expert in our source compares this to quantum tunneling.
Okay, I'm listening. How is a drone like quantum mechanics?
Well, in classical physics, if you hit a barrier, you bounce off. In quantum mechanics, a particle can sometimes just tunnel through the barrier.
And the drone does that to the landscape.
Precisely. A truck has to deal with the classical resistance of winding roads, mud, a bridge being out. The drone just ignores it. It uses the third dimension and flies straight over everything at 100 kilometers an hour.
It literally skips the resistance.
It does. They just drop the package with a little paper parachute right into the clinic's backyard. It made geography irrelevant.
Okay, so we have the spacesuit boxes, the camel kegs, and the quantum drones. But there's one more layer here that I found surprisingly philosophical. It's about trust.
Ah, yes. Schrodinger's vaccine.
Exactly.
Yeah.
So you're a nurse in a remote clinic. You get a box. How do you know it stayed cold?
And you can't just open it to check.
Right. The moment you look, you might ruin it. So until you open it, the vaccine is both alive and dead.
And in medicine, maybe is not an option. You can't give someone a placebo and tell them they're protected.
So how do you know what's in the box without opening it?
Digital twins.
It sounds like pure sci-fi.
It's basically a digital shadow. Those sensors we mentioned are constantly updating a model of the vaccine in the cloud. The physical vial and the digital data are entangled.
So if the real box heats up on a tarmac,
The digital twin on a server instantly updates to damaged. You don't have to guess. You look at the digital twin.
but then you have a security risk, the human element.
Right. What if someone messes up $1 million shipment and then just hacks the database to change the temperature log?
That is a terrifying thought, faking the cold chain.
And that's where blockchain comes in. And I know blockchain is such a buzzword,
I was waiting for it.
but the source explains it with this metaphor of amber, like a mosquito in amber from Jurassic Park.
It's fossilized.
It's fossilized. Once that temperature data is written to the blockchain, it's immutable. It cannot be changed.
So the trucking company couldn't go back and hide a mistake.
Impossible. It reduces what they call information entropy to zero.
And the source says this completely redefines the vaccine passport. It's not the QR code on your phone.
No, that's a user passport. The real passport is the vaccine's own travel history. This vial traveled from Tours, Belgium, and never left minus 70 degrees.
That statement is the passport.
And if that history is broken, the vaccine has no identity. It's just sugar water.
It's just amazing. That tedious data log was the only thing standing between a life-saving drug and a useless vial.
We were forced to build an infrastructure of truth.
So let's zoom out. We've covered thermodynamics, quantum tunneling analogies, blockchain. What does it all mean?
Well, it changes what logistics even is.
Yeah.
The word comes from the Greek logistikos for calculation, and later the French logistique for military supply. Logistics was always about war.
Moving ammo to the front.
Exactly. But this was a different kind of war.
A war against disorder.
It was. We didn't use logistics to destroy. We used it to project order, to save. We used the coldest temperatures and the most unfeeling machines to restore the warmest thing we have.
Human connection.
Right. It was a thermodynamic pause, as the source calls it.
We didn't beat nature, we just borrowed some time.
We created a temporary bubble of order in a chaotic universe, just long enough to get the medicine into an arm.
It makes you appreciate the invisible systems all around you. You only notice them when they break.
Which is the sign of good logistics.
Well, that brings us to the end of this deep dive. But before we go, I want to leave you with a final thought to chew on.
Go for it.
We talked about using these cold, hard systems to engineer trust in a vial of medicine. We froze its truth in place so it couldn't be corrupted. In a world that feels increasingly chaotic, where facts are slippery, it makes me wonder, what other fragile things in our lives could be saved if we treated them like these vaccines?
What do you mean by that?
I mean, things like our history, our news. If we could build a cold chain for truth, a way to freeze the facts in place so they can't be distorted by the heat of politics and opinion, what kind of stability could we build?
The cold chain for truth. That is a fascinating question.
Something to think about. Thanks for listening, everyone. Stay curious.
And stay warm.
That's all for today's episode of Lab 42. If you enjoyed this story of impossible engineering, leave us a review. Safe travels, hitchhikers. See you in the next galaxy.